Assuming we'll have to change this electrical motor with a gearbox. How do we go about changing this? If it is faulty. Hello viewers. The nominal current for this motor was 4.5 amps. But the MCCB, the protection, was set at 10 amps. That is double of what it should be. You know what happened? The motor got so hot that the fan burnt out. And the motor has burnt out. The motor has burned out. So today we're going to dissect how to change this motor without removing the gearbox. This is going to be a big job to remove the gearbox. So first of all, we're going to test this motor, and then to see if it's, how to know if it's still good or not. If it's not good and the gearbox is not affected, we can just take out the gearbox. We can just take out the motor. But to take out the motor, all we need to do is to remove these nuts. I'll show you. I'll bring it closer. See, there are about 4 nuts around here. See these 4 nuts? We remove them. Don't remove this one. If you remove these ones, it's going to affect the gear of the gearbox. So if you remove these ones and you pull them out. So we'll see, we'll do it now and again. We had done it before. But first of all, we're going to test the motor to make sure that the motor is bad before we change it. So first thing to do is to do we're going to do a continuity test on the motor. So we're going to open the terminal box. We're going to remove the configuration. This one is configured in star. So if we remove it, remove the configuration plates, make sure you keep everything where, well, so remove the configuration plates. And we can test them with an ohmmeter. I have a clamp here which works as a voltmeter for AC voltage, a voltmeter for DC voltage, and an ohmmeter, and also for current ammeter. So it works as an ammeter, ohmmeter, voltmeter. So now we're going to use it, set it as ohmmeter. We put it in ohms, and then we test to see what the readings are. First of all, we test U1 with this open loop, U1, and I don't know, it's not listed. We see an open loop here. We have another, we have six ohms. So we assume that this is U1 and U2. So we have 6 ohms, which is all right. So we go U1 and V2. There should not be continuity with them. So it's still open loop. So we do the same with earth, with chassis. You see, there's continuity with chassis. So this has there's a communication between this motor and chassis. You see, anywhere you test it, so already it's telling you that this winding is bad. So we go to the next one, test it with this one, open loop. So this is 3.3 ohms. This winding is still good. If you test it to earth, this winding is good. It's not linked to earth. So that first winding is bad. We go to the next one. Okay, it's 3 ohms, which is good. 3.5 ohm, which is good. Try with the next one, open loop. With the next one, open loop. And with the chassis, bad. So we know that one of the windings is bad. So with this, the first winding, which is this one, we know that it's burnt out. That's burnt out the winding because it's communicating to earth. It's communicating to Earth, so we know that it's bad. So now, how do we replace it? To replace it, all we need to do is to undo these ones closest to the motor. If you undo this one, you're going to open the motor. So undo these ones. Once you undo them, you don't have to take away the gearbox because it's going to be very heavy. And you can push it out, put a screwdriver in if you have to. But when you push it out, this is what it looks like. This is what it looks like. And this is the gearbox. So you see, this is a gearbox. So this is this plastic is here to avoid creating friction between them. So this is how you replace an electric motor. So all you do is that you get another motor. While this is still mounted, you get another motor and you insert the motor and you tighten it, and that's it. So that's how you change. That's how you detect if a motor is faulty, and that's how you change the gearbox. But remember, the MCCB does not have to exceed the nominal current of the motor. This is a 2.2 kilowatts motor, and the nominal current for it when it's configured in star is a 4.56 amps. So this MCCB goes from 4 to 6 amps, 4 to 6.3. This MCCB goes from 4 to 6.3 amps. It is good for it. You can use it for it. But this other MCCB is 6 to 10 amps. It's going to be too big for it. So it's not going to be good for it. So well, I hope you enjoyed this video and I hope you learned something. Don't forget to subscribe and don't forget to like this video. See you on the next one.